Alright, so now we're going to do a bunch of examples of evaluating radicals. And most of these are going to come directly off of your perfect square or perfect cube lists. And so things like the square root of 169, of course, the number whose square is 169 is 13, so the answer to this is 13. Cube root of 343, well, the number whose cube is 343 is 7, right? Because 7 times 7 times 7 would give you 343. That comes off of our list. Also, roots can be split up across fractions. So you can take the square root of something like 16 over 25. You just take the square root of the top and the square root of the bottom, and you get 4/5. Okay. You can also split up cube roots. Okay, and that's because they follow the exponent rules that we've talked about before. Could do 64 over 125. Cube root of 64 is 4, and the cube root of 125 is 5, and that also is 4/5. That's interesting. Okay. Now where it gets a little more difficult is with decimals. You know, fractions, decimals, we can work with the square roots of each. And so let's try something like 0.0009. Okay. What's interesting, if you'll remember with decimals, is that when you multiply decimals, you add up the number of decimal places in the answer, or for the answer. And so if I need to, well, first of all, the square root of 9 is 3, right? So I need a 3 in my answer. But I need to also figure out how many decimal places will be in the answer. Well, if this final answer has 4, if the original radicand has 4 decimal places, that means the original problem must have had, or the original number must have had 2, because when you square it, you multiply by itself. So you'd have 2 and 2 number of decimal places to get 4 total. So this will end up with 0.03. Okay? And the reason that makes sense again is because 0.03 multiplied by itself would essentially have 3 times 3, which is 9, and then 1, 2, 3, 4 decimal places. So you need 1, 2, 3, 4. That will give you the correct number of decimal places. So in the end, you take the total number of decimal places, which here are 4. I'll call them DP, 4 DP, 4 decimal places. The final answer should be half of that. Okay? So you cut them in half to get the correct number of decimal places. Okay? For a square root. This works for a square root. It'll be different for a cube root. We'll talk about that in a moment. Okay, so let's try another example. Let's try let's go 0.000049. Okay. Well, obviously the answer is going to have a 7 in it, right? Because the square root of 49 is 7. What I need to do is figure out now how many decimal places will be in the answer. Again, it's going to be half of the number of decimal places in the radicand, which is the stuff under the root. So 1, 2, 3, 4, 5, 6 places here means there's going to be 3 in the answer. So 0.007 gives us 3. Okay, so here again, there are 6 decimal places. Take half of that. In the answer, I should have 3 decimal places. Okay, for the same reasoning we did, or we had in the previous example. All right, now with an example with a cube root, could do something like the cube root of 0.00001. 0.64. All right. Again, here there are 6 decimal places. But with a cube root, remember you're multiplying 3 factors of the same thing. And so the question then is, how many decimal places would you have to add 3 times to get 6? The answer would be 2. So your final answer should have 2 decimal places. And because the cube root of 64 is 4, the answer will be 0.04. Okay, so here we had a total of 6 decimal places. But with a cube root, you want to divide by 3, or take a third of those decimal places for the answer. So here you end up with 2 decimal places in your final answer. Okay. All right. Now, you can also do roots of larger numbers. Things like 250. Oh, I just put the comma in the wrong spot. That's awesome. Let's do. I can't do 25,000. Let's do. Well, let's just scribble that out and do a different problem. Just wrote it wrong. Let's do 250,000. That'll work better. Oh, there you go. 250,000. So with 250,000, you do the square root of the 25, you get 5. And again, we need to look at the number of zeros here. So instead of decimal places, we're going to look at zeros in the larger numbers. Because when you're dealing with larger numbers like multiples of 10, the number of zeros add up rather than the number of decimal places. So here, I've got 1, 2, 3, 4 zeros. I need 2 then in my answer. And the reason for that is because if you were to take 500 and square it, which is like multiplying by another 500, then you would do 5 times 5 is 25, and then you add up the number of zeros. So 1, 2, 3, 4. 1, 2, 3, 4, and that gives you 25 or 250,000. Okay? So in the decimals, you're adding up decimal places. In the larger numbers, you're adding up the zeros. Okay, so here you would cut the zeros in half, where here you cut the decimal places in half. Okay. The only other thing that you really need to know for this section is going to be what to do if you take a square root of a negative number. Okay. Well, the answer to that is something unknown at this point. To find the answer, to figure out what that is, you would have to take that question mark and square it and get negative 25. Right? So that's the equivalent form. Square root is the undoing of a square. So what squared is negative 25? Well, think about this. That means that the question mark would have to multiply itself to get negative 25. Remember, if these are the same thing, then they're either both positive, so it'd be positive times positive, or they'd both be negative. You can't have any other combination because they have to be the same thing. But in both of those cases, you get a positive answer. It's never negative. Okay? Positive times positive is positive, negative times negative is negative. So you never get a negative answer, you always get a positive. Okay? And so there just isn't a number that works there. It doesn't exist. Okay, not a real number anyway. And so we would say that the square root of negative 25 is not a real number. Okay? There is something that mathematicians use for that. We're not going to talk about it in this class, but it is called an imaginary number or complex number. But for now, all we're going to deal with are things that have positive roots or positive values under the root. And if it's not positive, if it's a negative under the root, it's just not a real number.